Got to give the people in 2019. Give the people what they want. Yup. Back doing this thing again, getting back in the routine. Let's get right to it. It's been like a month since we've had regular class. Hopefully you guys had a good break and all those good things. I had a pretty decent time. Got so much stuff to do, and I know y'all are gonna hold it down. You killed it first semester, so we're in good shape. Let's keep it moving, folks. All right, so you know the drill. Pause it when you need to. I'm gonna go fast for those of you who are fast, but you can pause it if you need to take a little more time. All right, we're talking about domain and range today. All right, so first let's talk a little bit about these symbols. All right, so first we have the greater than, less than symbol. We have this new symbol that we're going to use to show domain and range notation. It's kind of these parentheses symbols. It means the same thing as greater than or less than. And we have the open dot. You've seen these before. You may not have seen this as much before. The thing to remember, though, is the number that is connected to these symbols is not included in the set, right? So if I say something is greater than 5, 5 is not greater than 5, so 5 is not included in that set. 5.1, 5.2, 6, 7, 8 are, but 5 is not, because 5 is obviously not greater than 5. Alright? So now we got the less than equal to, greater than equal to signs. We have these brackets, which means the same thing basically as the less than, greater than, and equal to signs. And we have the closed dot. All of these symbols mean that the number that goes along with them is actually included in the set. So again, if I said, something is greater than or equal to 5, well, 5 is now included because 5 is equal to 5 and everything above it is greater than. So really most of this you know, just remember that these brackets also mean it's included, similar to the greater than or equal to sign. Again, some quick reviewing on domain and range. Your domain is a list of all your possible inputs in a function, which many times in math is going to be your x values. Those are your domain. But depending on what your function is talking about, you might have other things besides x values. But a domain is a list of all your possible inputs, and the range is the list of all your possible outputs. Again, those are your y values in this situation, many times what we use in math. And as we're talking about graphs here, we're mainly going to be talking about x and y values. All right, so make sure that you have that down. You might want to pause it right here and draw these two graphs if you haven't done so already. We're just going to do a quick recap on how to find the domain and the range of these graphs, okay? So when I'm looking at domain and range, first my domain is my possible x values. So I'm seeing, as I'm moving to the left and to the right, what are all the possibilities where this graph is going to actually be happening, okay? So I start here. I see this arrow is going, which means this graph is going to go forever and ever and ever and ever in this direction. So this graph is going to go to forever in this direction. So my graph to the farthest left on the x value is going to keep going to negative infinity, right? It's just going to keep going that direction forever. I can't put any fence, I can't put any cutoff on here. It's going to keep going to negative infinity. So x is going to be anything that's greater than negative infinity, right? Because we're talking about x values. Now I'm looking in the other direction. As I'm moving to the right, I'm going to keep going, until right here my graph stops. It's like an invisible fence. Happens right here. I can fence it in. Nothing ever happens past this point. Now notice this point, 1, 2, 3, 4, 5, is actually included. So that means this is a less than or equal to, because x, this number, is included. So it goes all the way from negative infinity up to 1, 2, 3, 4, 5. And it can't equal 5. 5 is included. Everything between these two numbers is my domains. This is where the graph is happening. Everything less than here. But there is a second way that you can write that, all right? So the other way that you can write it, which is newer, which we haven't seen before, is going to say right? I have here, I have negative infinity, and that's not included, so I use the parentheses. I have 5, that is included, so I use the bracket. That's the new thing. I'm just mirroring this. I'm just really taking this middle part out of it. So it goes from negative infinity to 5. Negative infinity, you can never touch negative infinity, and 5 is included, and it's touching it, so it's bracketed. Okay? Hopefully that made sense. Now I'm going to do the same thing in the range. I'm looking at this graph and I'm looking how high and how low can this graph possibly go. I like to move from the minimum, how far minimum to maximum. I like to move from minimum to maximum. So I'm seeing here, and I'm seeing this thing is pointing down and out, so it's also going to keep going farther and farther down, right? So again, it's a negative infinity. Oh, that's an 8. It's a negative infinity in this direction because as it's going outwards, it's also continuing to drop down, lower and lower. And this is a range, so it's greater than negative infinity. This is a y. Now as I'm going higher and higher, again I'm looking on my y-axis, and I'll do this with the ruler. I'm seeing, oh, nothing ever happens above this point right here because it stops. It's never going to get higher than that because the graph stops right here. And that's at the point 1, 2. So I get the point 2. And now it's just a question, does it actually touch 2? Yes, it's included, so it's less than or equal to 2. And again, if I'm going to write it in my other type of notation, it doesn't touch negative infinity because it can't. And it gets to 2, and it touches it. That's what that looks like. So there's the domain and the range for this graph that you have. Now I'm going to move over to this graph. I'm thinking domain. I'm thinking left and right. This is a parabola, so I see this thing. It's going up. It's going to spread out this direction. It's going to spread out this direction, so it's going to keep getting wider and wider, which means there really are no stopping points. So the domain really is from negative infinity to positive infinity. It would keep spreading out in both directions along the x-axis. Or you can say all real numbers, right? Basically, every value of x would be included on this graph. I can't really put any cutoff points in either direction, moving left or right. Now I'm going to move bottom to top. Well, if I go down towards the bottom, I see nothing ever happens below about this line, right? If I'm going down, right here's where it stops. I'm never going to get any of this picture down here. If I'm moving upwards, I see this thing is also going to keep going up and up and up and up, so I can't really put a cutoff line. So I do have a cutoff in here. Ooh, I forgot one thing though. Let's do this one. This would also say negative infinity, never touches to infinity, never touches. All right. Now we can get into the range. So I see the lowest it ever goes on this y-axis is 1, 2. Now the question is, does it touch 2? Is that included? Yes, it is. So it's less than or equal to. This is y. And then the highest that it keeps going to is infinity because it's going to continue to move up and up and up because it has these arrows that are showing me that. I can't touch infinity, so it's going to be that. So it goes from 2 to infinity on the y-axis. So again, 2 to infinity. And excuse me, it touches 2. So that means this should be a bracket from 2 to infinity. That's domain and range. Okay? That's all I'm going to give you on this one. This is mainly a recap. You did this last year. You probably did it some in 8th grade. You just want to make sure that you've seen it again. Video number 1 done. Hopefully most of you are walking in the door seeing this. Thanks. Looking forward to getting this going in class today.